We're starting chapter 4, starting with 4.1. We're looking at local maxima and minima. Now, before we get into the topic, we need to introduce an idea called the critical point. Okay, so a critical point is very easy to find. It's the value, the p-value, when f prime of p is equal to 0, or when f prime of p is undefined. That's called a critical point of the function. And when we have the coordinate of that point, right, p and f of p, in that case, it's also called a critical point, and f of p is called the critical value, right? So the first thing we want to know is how to find a critical point, right? For example, let's say I have f of x is x squared minus 2x. Then f prime of x will be 2x minus 2. So to find critical point, set f prime of x equal to 0 and solve. Right? So f prime of 0 would be 2x minus 2 is equal to 0. And then you go ahead and solve that, you get x is equal to 1. Right? And then when you have to plug in 1 into f, so f of 1 will be 1 squared minus 2, so negative 1. So the critical point we have is 1, negative 1. Okay. So the goal to find critical point is that at these points, specific points on the graph, that actually gives us a very interesting behavior. All right, so let's say I have a curve like this, and then we're going to pick 3 points, A, B, and C. Okay, then we're going to look at the f prime of these values, right? So at A, it's increasing, right? So f prime will be positive. At B, it's a flat line, so f prime will be 0 because it's not decreasing or increasing. And then at C, it's going to be negative, right? So we can see something like this. At the highest point of the curve, we get f prime is equal to 0. Right? So that's pretty interesting, because if we can find out when f prime is 0, then we can determine whether it's at a peak of a mountain or at like the foot of the mountain. And that's what a local maxima and minima is. All right, so here we have the definition for a local minimum and maximum. So f has a local minimum at p if f of p is less than or equal to the values for f for the points near p. Right, so cases will be like this, right, where you have a curve like that, and this is your point p and f of p, right? So the value of f of p is less than the value that is close to p, right? So this will be a local minimum, whereas a local maximum will look like this, right? Where your neighboring values are lower than f of p. Right. Now, of course, there are many different ways to figure it out. So let's take a look. So one way to determine whether your critical point is a local minimum or a local maximum is by looking at the sign of f prime to the left and the right of 0, right? Let's say this green line represents f prime. Okay. And then here, exactly at p, we know f prime is 0, right? So f prime is 0, meaning to the left and right, they must be increasing or decreasing, right? So if it's a local minimum, means it has to decrease first, right? It has to go down slope first. When it reaches the lowest point, then it starts to increase again, right? And that will give you a local minimum from negative to positive, right? So critical point, negative to positive, means local min, okay? And on the other hand, if we have 0, f prime 0, and then it's increasing to 0 when it increasing and stop increasing, so you have reached the top of the mountain, and then you have to calm down, right? And then that becomes decreasing, right? So when f prime goes from positive to negative, it means a local max. Okay. Right. So here is some definition for you. Right. Suppose P is a critical point for a continuous function f moving from left to right. And this is what we have over here. F prime changes from negative to positive, right? Negative to positive, then f has a local minimum at P. If f prime changes from positive to negative, which is what we have here in red, then f has a local maximum at P, right? So when you find a critical point, you want to determine whether that is a local min or a local max. Another way to say this is it at the bottom of the mountain or at the top of the mountain? Okay. And let's look at some example. All right, so here we have first example, f prime. F of x is x cubed minus 9x squared minus 48x plus 52. And here they have given us the f prime and f double prime already. So it's some ideas that we can use. All right, so even though on the graph here, they actually label everything here, but let's try this out with from scratch, from showing all the work. All right, so first we want to find critical points. Right, and to find critical points, first we need f prime. Right? And since that's a polynomial, taking the derivative of f is pretty easy. You just do the basic power function rule. Right, so we have 3x squared minus 18x minus 48. Set those equal to 0 and solve. All right, so we can divide by 3. I get x squared minus 6x minus 16 equal to 0. And then solve that. I get x plus 2 and x minus 8 is equal to 0. So x is negative 2 and 8. All right, so we can double check. All right, at negative 2 and 8. Right now, without looking at the graph, how do you determine whether you have a local min or max? Right, the way to do this is first we're going to draw a straight line, right, and label our critical points, negative 2 and 8. And here we are going to find the f prime, the values of f prime. Now we know at negative 2 it's 0, and at negative 8 f prime is going to be 0. So we have 3 places to fill in f primes, here, here, and here. And we're actually not going to worry about its actual value. All we care about is the sign, whether f prime is positive or negative, meaning whether f is increasing or decreasing. All right, let's take any number to the left of negative 2. Let's say I pick negative 3. Right? So go ahead and plug in negative 3 into f prime. See if we get a positive number or a negative number. All right, so it's actually, we can actually rewrite this as 3x plus 2, x minus 8. All right, so let's see, 3 times negative 1 minus 11. So negative, negative, that's positive. That means this is increasing. Okay. All right, next. Let's try 0. Right, 0 is always nice to work with. So f prime of 0 would be 3 times 0 plus 2 times 0 minus 8. All right, so that's negative. All right. Negative. All right, last but not least, let's try say 9. Right, so f prime of 9 is 3 times 11 times 1, which is positive, right? So positive here. All right, now we can see pretty clearly the critical point at -2 went from positive to negative, means it's increasing and then stop and then decreasing, right? So here at 0, we actually have a local max, right? On the other hand, for the critical point at -8, it was decreasing to 8 and the increase after 8, right? So here we have a local min, local minimum, right? And that's what we have up here, right? Local max at -2, local min at 8, and then it's increasing to local max, decreasing to local min, and then increase afterwards. Now, one question you might ask is, okay, if it keeps on increasing, then there shouldn't be a maximum, right? Or minimum because it's decreasing. All right, so this is the idea of local max and min. We are looking at the maximum value and the minimum value locally, not globally. All right, so we're just worrying about where uh, f prime changes sign, and that's where our critical point occurs, and that can be either a local max or a local min. All right, next we can actually look at f prime and then determine whether it's concave up or concave down. All right, so here it looks like it's concave down, right, at -2. Right, so f prime, f double prime of -2, f double prime is 6 times -2 minus 18, right? F double prime is up here. Okay. So that would be -12, -30, right? Which is negative. So it means it's going to be concave down, right? A cap right here, right? Now you can see that from the left-hand side to the right-hand side, it becomes concave up, right? So somewhere in between here, it's going to change from concave down to concave up. Right. So let's see. F double prime at 8 should be up, should be positive. Right. So 6 times 8 minus 18, that's 30. Right. Positive. So it means it's concave up. All right. Now we will learn about how we can determine where it starts to, where the point of changing from concave down to concave up is in a second. Now, here's another way to determine local max and min, right, using the second derivative test. Right. So if f prime of p is equal to 0, means we have a critical point. Right. And if the concavity is positive, if it's concave up, then it has a local minimum at p. If it's concave down, then it has a local maximum at p. Right, think about this. If it's concave down and then f prime is 0, right, it has to be here, right? So that gives you a local max. Now, if it's concave up and f prime is 0, then that'll give you a local min. Right. So there are basically two ways to determine whether you have a local max or min. Right. One is the first derivative test, which is what we're doing here with the changing of f prime. Or another way is simply find the second derivative and determine its concavity at those critical points. Right? And if f double prime is 0, then it tells us nothing. Right? So sometimes the second derivative can be inconclusive as well. All right, so let me use this example to show you how we can use the second derivative test to find local local min and max. All right, so first we need to find f prime. All right, so that's 3x squared minus 6x plus 3. And f double prime is 6x minus 6. Okay, so that's good. And first, after you have found f prime and f double prime, go ahead and find the critical point by setting f prime equal to 0. letting f prime equal to 0. So we have 3x squared minus 6x plus 3, which gives us is equal to 0. Right? That's x squared minus 2x plus 1 is equal to 0. That is x minus 1 quantity square equal to 0. So x is 1. Right, so x equal to 1, we have a critical point. Okay. Now exactly where that critical point is, we can plug that in back into 1. So that's 1 minus 3 plus 3 minus 11. So what is that? Negative 10. Right. So that critical point is at 1, negative 10. Okay. Now let's determine whether that is local min or max by using second derivative. All right. So x f prime f double prime, like that. Okay. So the x value, the critical value we're looking at is 1, and f prime is 0. Right? That's plugging 1 into f double prime and see what we have. So we get f double prime of 1 is 6 minus 6, which is 0. Right? So 0. F prime and f double prime are both 0. So by the second derivative test, it tells us nothing, right? So it's inconclusive. Inconclusive. Okay.